Good morning, everyone. Embedded Monk here, cool cap here, and today's embedded adventure day 9. Soon I'm gonna run out of my fingers to name them, I hope so. And today we're finally, I hope we're finally doing the HTTP server for the remote LED control project. I even prepared the table camera again, so nothing changed. Here is the breadboard, here is the circuit that we assembled in, like, I guess, on day 1 of Embedded Adventure. Yep, so many of you guys haven't seen it, so you can check this out on my channel. And so I hope we'll be able to actually make an HTTP server and try it out. And maybe tomorrow or even today, I don't know, we're gonna test it on the circuit. I hope that this plan will work. So let's go. First of all, I'm just gonna create a new project here because these Wi-Fi experiments, they're actually pretty cool, but okay. Let's just move on from experiments to a real project, to the remote LED control. So let's go and create that thing. Create project. How would we call it? How will we call it? Let's just call it like LED HTTP. I don't know. Something like that. Okay. So we created it successfully. And first of all, let's steal the function with connection to Wi-Fi because it's really important. It's really important. And by the way, let's also make a function to DNE to Wi-Fi because it's really important to DNE all the driver things and so on. So let's just make the Wi-Fi off. I don't know. Okay, and let's just put this here. Okay, let it be. By the way, we can actually put these functions to some utils header just to clean things up. So let's just go here and create the utils header for that purpose. Yep. Sounds not really good sounding because we forgot to include some headers. Yep. Let's now include them. Okay. And here just include the utils file. Also, the one thing that I forgot is to actually put these libraries into CMake lists. So let's just put them here. Okay, requires. That's correct. Okay, and now let's just see. In previous series we found the HTTP server API. So I'm gonna, one moment. Yep. I'm gonna just check that, like ChatGPT said that there is some kind of server API. So we tried to actually make something with the client API. So we actually successfully send a request to the httpforever.com and got the error code okay. And now we want to receive requests. So okay. Let's just see what to check. Let's just Google the docs. HTTP D. Okay. Okay, so the HTTP server component provides an ability for running a lightweight web server on esp32. Feels like my monitor is kind of one moment. Nope. Perfect. Instance of HTTP server. Allocate memory resources for it depending upon the specified configuration. 100% handled service instance has both listening socket TCP for HTTP traffic and a control socket UDP for the control signals. Okay. In a round robin fashion. Passing config D to start. Okay, let's just check this function here. So starts the web server, create an instance of HTTP server and allocate memory resources for it depending upon the specified configuration. You know what? We can actually create the server config. So we should put it here, the handle and the configuration. So the configuration, let's just create the default one. And by the way, let's just do some basic stuff here. By the way, we should also make these things work. Not only connect to Wi-Fi, but also this thing. So let's just also make a separate function for it. I don't really want to put it in separate places, but okay. Native init, I guess. Let's call it like this. Yep. VS, etc. Creating event loop here. Okay, sounds okay. Let's just put this function here. No, here. And just for a quick experiment, we're gonna that creating event loop, for example, inside this function doesn't break anything. So let's just call the this init function. Then we'll call the connection, and then after a certain time we'll try to de-init it. And I'll just hit the build, and we're gonna continue to read about HTTP servers. Okay. Just to check that it doesn't break anything. If it does, I will just hard code all that stuff here and get rid of this fancy utils header. Yep. Okay. Okay, let's go here. Let HTTP, because you know, the building process for the first time will take a long well, it will take some time. By the way, I will have to sacrifice the table camera, sorry. because I don't have enough USB ports here. I'm gonna buy some USB hub. Connected. Okay. Let's put this on build. Flush. Okay, while it's building, I will just continue to read about the HTTP server. So, we must create HTTP configuration, and then create some handle for HTTP server, and it can be empty. But what is the HTTP handle itself? HTTP server instance. Alright, okay. So it's basically an object. Okay, then HTTP stop, we put the handle here. Okay. And by the way, it's not the pointer here. That's strange. Okay. Like, I want to just check the function that we can handler URIT. What is it? Like how to work with this. URI handler. And what is URI handler? And URI handler is just some kind of handler function that is called when we get a certain HTTP request on a certain endpoint. Yep. And that's how we register them. As far as I understand. So seems pretty easy actually. Seems pretty easy. So we need to create the HTTP handle, HTTP server handle, then register all that stuff. Just in every just like in every backend framework, like Fast API in Python, or well, I haven't used any like besides I didn't know like Django maybe. Yep. So it's still building. Oh my gosh. Yeah, I told you guys that will take some time. Okay. But it seems seems pretty easy, I guess. So if there won't be any problems here, I guess failed. Multiple definition of native init. What? First defined here in utils. I guess it just have the conflict of names, like let's just call it something like I don't know, native not create, but I don't know, like setup, native setup. Okay. So let's just wait a bit. By the way, guys, I want to say thank you for all your support. I'm reading your comments. That's like really inspiring me to continue that thing. Even though I don't have really much time, more like doing it just 1 hour every morning and shutting it on YouTube. So that's pretty cool. That's pretty cool that you support me, guys. Thank you. Thank you. Okay, so let's just monitor. Is everything okay? Yeah, everything okay. It connects and it successfully DNS without any errors. So let's now do some HTTP stuff. Let's create the I'm just gonna leave this page and just see the HTTP start method. So we should create some empty handle that will be given some basic so that's just a server handle, and then we create some default configuration. So http dconfig t config. Well, let's just make a default. Yep. Default config. Okay. And then we finally started. Okay. And once it's started, we can register the URI handler. And the URI handler, we'll make it with the proper signature. Okay. Configuration. Okay. So let's just make it if well, I don't really want to actually process any errors. I'm too lazy for it, but okay. If we can register handlers only once, like only if the errors are, everything is okay, then httpd start the server handle in the http config here. So if it returns the esp okay, then we can finally register stuff. So I'm just gonna remind you an idea, guys, that I wanted to actually make a remote control of LEDs. So I'm gonna do 3 endpoints, one for red LED, second endpoint for yellow LED, and third endpoint for green LED. I'm just gonna show you if it's not too complicated. Yeah, I'm just gonna show you. Okay. One moment. Yep. Okay, so just wow, I'm just behind my table. Cool. So I'm just gonna show that if you haven't like really see that properly, I have like 3 LEDs here when I was building the traffic light in the first series. So there is a red one, a yellow and green LEDs, all connected properly with resistors. Yeah, of course, electricity, you know. And we're gonna place CSP here. It connects with the haven't remembered exactly the pinouts that I was using, but we're gonna remember it, recall it, and I will just interact with it. Okay, so let's back to developing stuff. Okay, so just gonna check this thing. HTTP URIT. URIT. So this will be a red URI that will have certain parameters. I guess we'll go with get HTTP requests. We don't really need to send data, we just need to toggle the endpoint and that's all. So yeah, URI will be the red one, just red. Then HTTP GET will be the method. So that method will be the HTTP GET. That's all. Handler. Yep, and here we go. We must create handlers. So I'm just gonna copy the signature. Yep, and let's just call it red URI handler. Red URI handler. And here I'm gonna just actually copy paste the code that we were writing in traffic light thing. So I guess I should use, let's just use this very useful headers and very useful macros. Yep. And also we're gonna reset all pins. It is a necessary thing. Let's just do this here. Yep. We're just gonna reset all of them. Firstly, when starting a server, and yeah, and we should also get somehow we should also invert the level. So when I toggle it the first time, it turns on. When I toggle it the second time, it turns off. Let's make the following logic. I'm just gonna Google the GPIO get level. Is there anything something like get level? GPIO get level. Yep, we can actually get input level, not output level. Or what? For input or input and output, the return value is always 0. Not cool, not cool. Can we get level for the output or something like that? We can actually make the static variable here. Static state. Yep, it is currently 0. We'll just toggle the static, yep, static integer. Well, we actually don't need to waste so much memory for just an integer, so we can actually use something like uint8. Yep. And then toggle the LED with the state. Yep. And let's just make the same thing for all of LEDs here. So red, yellow, and green. Here we'll have the yellow GPIO, and here we'll have the green GPIO. Green GPIO. Okay. So when we'll toggle the red one, the handler will be the red URI handler. By the way, what is the user context here? I'm just curious. User context. Should be URI. Pointer to user context data, which will be available to handler. We don't actually need it. The only thing we need is actually just handler, just method, and just URI. Everything else should be nulled. If it's not nulled by default, which I hope it is. So y2. Okay. Let's just leave it. Okay. I'll create the same thing for all of 3 LEDs to control our fancy traffic light. Not fancy, just regular one actually. Yellow and green. Yeah, by the way, I should also toggle handlers green and call them differently. So okay, red, 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 yellow, 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 green, green, green. Okay, and then I just simply register them with HTTP register URI, passing here the server handle and the red URI. Well, maybe I should pass the pointers here. Yep, pointer, okay. Passing pointers. Yellow and green. Alright, so we registered all the endpoints. How to run that thing? How to actually run the server? Sorry guys. Memory source very depending upon. So I guess just after the start thing, so 0 with the provided handle, and frees up any associated memory resources. Okay. So I guess when it started, I just registered all that stuff, and let's also make the turn off endpoint just to turn off that thing. What if we don't want to any of HTTP? By the way, I guess I'm mistaken. A mistake. Yep, HTTP D. YD. I don't know. Okay. Let's make the endpoint for stopping everything. Yep. Remotely. Stop URI. If it's toggled, if it's toggled, yep, with HTTP GET, we're just gonna, yep, let's create a handler for that thing. We'll call it stop URI handler. Yep, also we'll register it as well. desktop URI and just create it as other ones. SPRT. Okay. Just two lazy rows. Yep. Okay. And here we're just gonna put the I guess we actually should pass here the server handle. We should pass here the server handle. And so this is where the user context will be actually useful. We'll just to the user context data which will be available to handler. Yep. Okay, will we be able to get it from the request, or is just like globally available? Okay. Okay, no docs. Request T. Handle method URI. Yep, we'll be able to access it via user context. So let's just put the user context here and kill the that's actually interesting because we're killing the server remotely. That's like, you know, the backdoor for the as it's called in cybersecurity. It's just a backdoor. So server handle, sort of, yeah. Server handle. Okay, I'm just gonna check the does the HTTP stop needs. Yep, it needs handle, so we're gonna pass it there. Well, we can actually just turn the Wi-Fi off. It will just kill the server as well. But let's be more careful with that. So HTTPD stop. Stop the request user context. And by the way, we should pass it like that because it requires the value as far as I remember. HTTP stop. Yep, it requires a value here. So then we'll just call the Wi-Fi off. So we don't need actually to do any stuff here. We're just gonna process requests, and we can just loop the thing up. So we just can while like one return no, just while one, just empty loop. Yep, just empty loop. So actually that should work. That should work. Let's just try it out. I'm just gonna again plug in the ESP. Flash. Okay. No such file or directory. Cool. Why? Include driver gpio.h. Maybe I actually know. Wait a second. Driver gpio. Driver gpio. And here driver gpio, yep. Include errors detected. that include buffs trails are disabled for the translation unit. That's actually strange that it doesn't want to somehow connect with the GPIO thing. We can actually move it to utils, but it probably won't change anything. Or some of them secretly include this thing. Okay. Actually, no such file or directory. That's not cool. That's not cool. Provided by ESP driver GPIO components, however, it's not in requirements list of main. How? Okay. How then this thing worked without any of requirements here? Yeah, that's actually was pretty strange thing, but okay. Maybe when we explicitly specify that thing, that's when it want us to explicitly specify everything, not just only the modules we want, but also the default ones. Oh my god. Okay. Quest. Unknown type name. Okay. What should I include? What the fuck? English. Okay. Like, is there any header that I should include? Yeah, but I probably didn't include it at all because I haven't remembered including it. Let's just include it to utils, and also, as I suspect, I should put this here because it's a separate module. Yeah, but without the header thing. Okay. Let's flash it. Flash it again. Damn, ran out of coffee. Unused. Okay. Dereferencing void pointer. Yep. I understand all the impacts there. Use of void expression. No, I meant register. What the? I meant register pointer. Oh, register URI handler. Yep, mistake. A mistake occurred. Okay. Damn, I should install Vim here. Invalid use of void expression. Yeah, we should return something from function that should return something. Okay, so what they recommend to return esp-ok. Yep, we should return the esp-ok everywhere because we won't probably have any errors with GPIO. So seems okay. We can have some errors here in this function, but let's pretend that we're not gonna have some errors there. Use a void expression. Okay, 33rd. Use a void expression. Does it actually one moment, it's invalid use of void expression. I understand that I'm dereferenced the void pointer, but it's not forbidden in C. You can dereference a void pointer. You just don't know what to expect usually. Valid use of void expression. 33rd. Okay, let's just cast it to the I'll just cast it to HTTP handle T pointer. Yep, and dereference it, maybe it will help. Usually it's not safe, but we know that we passed there, what we passed there, so shouldn't be any problems. So let's link it. And see, will we be able to actually request something. Probably I will write some Python script to do this, but firstly I will check will it work from the, basically from the browser, because it should work from the browser. Yeah, but one more thing. the actual thing, yep. Damn. Let's just do this firstly without the GPIOs, yeah. Let's just firstly print to not assemble the circuit, which won't work. So let's just print red turned. Let's just put the state here, send D, the state, yeah, and by the way, state should also be inverted. And let's just copy that stuff here and here. Okay, so yellow and green. Okay, grape. Let it be grape, you know, that sounds cool. Flash that thing again. Damn guys, I have a water reminder, I have to drink some water, but I'm gonna finish the video. Stay healthy guys, stay healthy. Drink water, do some sports. Okay, flashing. Alright, perfect. Let's monitor it. So it connected. Let's try to request what the watchdog got triggered. Whoa. Timeout, backtrace. Okay. One moment. So what it tells us, got triggered, the following task users did not reset the watchdog in time. Currently running. Hmm. That's interesting. Let's just okay, so it tells us that we have some two tasks running on different cores because ESP32 is double cored, and we have some Wi-Fi task and some ideally one. Ideally one. Maybe we should stop the Wi-Fi thing when we connect it. So once we connect it, we can actually stop it. Maybe. Let's try. But it probably will lose. Well, what do we call here? We call here ESP Wi-Fi stop and ESP Wi-Fi deinit. So probably we can stop and not deinit. ESP Wi-Fi stop. Wi-Fi if mode is station, it stops station free station control block. If mode is AP, it stops the A3 sub block. Okay. So we actually don't need this thing. We actually don't need to deinit anything. Deinit Wi-Fi if real resource allocated, and stop Wi-Fi task. So only this function stops Wi-Fi task, not the not that thing. By the way, let's check the example. There was some example in the station mode. Like, do they find it STA? Whoa. Okay. So they initialized NVS, then ESP log level set, then they init that thing. By the way, they don't stop the Wi-Fi service. So we don't actually need to put this off. Well, what if we do? What if we... Oh, sorry. Grib, yep, grib. Hell no. Grib, yep. Okay, let's put it off. Wi-Fi off. Like, what will happen? I'm just curious. Flash. Okay. Waiting a bit. A little bit of waiting here. Finally. Monitor. Okay. So we just immediately deinitted this thing. And again, we just dropped, so probably that's not cool. I got triggered. esp-idf httpd. Yeah, please, where's, no, we don't have this Texas guy. Okay, environment details, not using the Wi-Fi for internet access, and my code does not use any Wi-Fi related APIs. The idle tasks should need to run in FreeRTOS for some housekeeping tasks haven't all been able to run for a few seconds. Case core that is hogging all CPU power and not yielding to other. When exactly you use a spin lock while variable 0. Damn, FreeRTOS is actually a very complicated topic. Maybe we should wait a bit after, after the, or we should somehow init this thing in different thread, maybe. Okay. I'm just gonna one more time just to reproduce this error. Let's just check again. Monitor. Blah blah blah. Finally connected. And falling. And falling again. By the way, we had a Wi-Fi task in the first time. Now we have the main task. But I just got rid of the Wi-Fi off here. That's actually strange, but okay. Okay, let's ask the very cool guy here. Yeah, let's just ask. Getting this error. Can you explain why? Your main task blocked the CPU for too long without yielding, causing the task watchdog timer to fire. Let's break down the message. Okay. With an idle task, the watchdog expects every task, or at least the idle task, to run periodically. If your task monopolizes the CPU, the idle task on that core cannot run. An infinite loop without vtask delay. By the way, yeah, that actually can be the thing, because let's just print the debug here. But yeah, if we are blocking here forever, other tasks are not able to actually do any work, so we can vtask delay, and vtask delay in FreeRTOS basically means that we allow other tasks, we put the main task into sleep mode for a while other tasks are able to do some cool stuff. Server started. Okay. Let's build it. Thank you, ChatGPT. Yay. I hope you guys don't mind that I'm using ChatGPT sometimes, because, well, ChatGPT is actually, you know, it's quite a good learning tool. You can actually stuck there for a few hours, answering and questioning a lot of things that it gives you, but it actually sometimes worth it. It gives sometimes a good understanding of some topics. So probably it's better to use it, but very carefully, very carefully. Okay, so let's monitor. HTTP server started. Connected, got IP. No problems. Okay, let's now request. Let's now do some requests. Yep. Okay, let's just, red. Well, let's just make a good successful request. Yay, red turned -1. It just doesn't return us anything, right? It does not return anything. So, okay, red again. I guess I just put the wrong value there. Okay. I don't know, yellow. Yay. Yellow again. Yay. Green or grib. Green. Yep. Grib. Let's call it grib. You know, grib is a cool word. It's mushroom in Russian, actually. If you didn't know, it means mushroom in Russian. Stop. Huh. Actually, it didn't. It actually hasn't done anything. That's actually strange. So we stopped everything, and now we're completely blocked. But as far as I understand, we can't now send any requests. Yep. So it's just dead. It's just completely dead. Yep. Okay. Probably that's not a good thing to do, but okay. Okay, let's go and connect it to the circuit, finally. And do that stuff on the circuit thing. I'm so excited, so excited. And by the way, we also should do yeah, by the way, it should work, because anyways, when setting the level, we're just taking the bit, we're not taking all of it, all the uint 8, so that's okay. So okay guys, I'm just gonna flash it again, and while it's flashing, I'm just gonna check the circuit. By the way, we can check the schema, actually. We can check the schema. Now let's just open the coolest website for schemas, Draw.io. I don't know, I just like it. It's quite simple. Let's just open the from device. Yep, documents now. Oh my gosh, embedded adventure. Traffic light, I guess. Yeah, here we go. Yeah, just to remember, this circuit was drawn in the... I guess it was drawn in the very first series, in the day 0. So it's very old, but nevertheless. So we connected the red one to D4, yellow to D2 and green to D15. So, damn, actually, I guess I wrongly flashed it. I shouldn't have done this. Let's just disconnect it. Disconnect this thing. Okay. And I'm just gonna turn on the camera so you can see the circuit. One moment. Finally, the moment of truth. The moment of truth. Table cam. Okay. So, oh yeah, finally it works without any. Okay, I'm just gonna turn the mic light. Oh. So it turns out table camera is a bit dead. So we should just, yeah. One moment, guys, one moment. Guess we all want to actually see how it works. Yay. Finally. Finally. Let's go. I'm just gonna put it downwards. Yeah, here we go. So, I'm just gonna quickly check the circuit. So I'm gonna just turn the lights a bit. Oh, you probably won't be able to see anything there, but okay, okay. Whew. Whoa. Let's put the cap here. That'll be not product placement. Okay. So if I have put it this way, so there should be enough space here. Yep. Okay, moment. So I'm just gonna quickly check. Oh no, probably should disconnect this thing. Put it here again. Okay, here we go. Oh my gosh. I'm just gonna quickly remove these wires from here because for some reason I can't just plug the esp32 the right way. I won't really destroy the circuit completely. Yeah, I just want to put the esp32 in the board. Yeah. Here. And now let's connect all of those. Okay. So this wire is red, and red should be. I'm just gonna quickly check where the red is. So the red is D4. Yeah, it's D4. Okay. This seems like a wire going to the red LED. Yep. So we should place it in D4. D4. 3v3, G and D, D15, D2, D4. Plugged. Okay. Now the yellow one, just gonna, yellow is D2. Yep, it's D2. So the yellow one goes here. This one seems like yellow. 3v3, G and D, D15, D2, finally. Here we go. And the green one is goes to D15, obviously. Yeah, it's just to, oh, okay. I just broke and hope the wire is okay. Okay, and then GND from the power line obviously goes to GND. Okay, esp32 unplugged again. Yeah, guys, I told you on the day 0 that it has some problem. It has some problem. It doesn't go full way into the breadboard, but it does work. It, you just have to be careful. Very, very careful. Yep. So, resistor goes here. Here is the LED. Okay. I'm just gonna quickly check the. Okay, this is the red. No, this is the green one. Correctly goes here to the resistor, to the green one, to the GND. Okay, this one goes to the yellow one, to the resistor, to the LED itself, to the GND. Okay, and this one goes to resistor, then to the red one, then to the GND. Well, it seems okay. So, okay, finally, the moment. Yep, I just disconnected the mic for a bit because otherwise I won't have any USB ports available, so hope you guys won't mind. I just plug it. Yeah, can just remove the microphone a bit. Yeah, plugging it in. Okay. For some reason, green one just turned up. Okay. One moment. I'm just gonna try to send some request. Red, for example. Damn. One moment. Wait. No, not working. Red once again. Actually pretty strange. Yellow. Whoa. Oh my gosh, guys. I'm gonna show you. Anyway, I'm gonna show you. Just, okay. Let's reset it. I don't know, for some reason green one. One moment. Just check. Yeah. Okay. Reset. Gonna reset it. Okay, and show you. So, yeah. Here is the screen. Here is the screen, guys. Okay. Here's the breadboard. Yep. Here is the screen. Yep. It is just should be here. Yeah. Okay. The breadboard is okay. Well, let's just make it like this, just to be more epic. Yay. Here we go. Here we go. Here we go. Oh my god. No, spoiler alert. Oh shit, I broke everything. Yo. Reset. Reset. Damn, how I like spoilers. Okay. Finally. Finally, the moment of truth. Let's turn the lights off. Let's turn the lights off. And now, okay. Are you ready? 3, 2, 1, go. Here we go. Well, it actually makes an HTTP request, like, it makes HTTP request when I just typed it. Finally, yeah. Yay. Okay, let's just yellow, 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 yellow. Please, 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 please. Boom. here we go. Here we go. Yay. And green, 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 please, 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 please. Green. Boom. So it works. Unfortunately, it does not work at all in the other way. I'm just gonna quickly fix it. So let's just quickly fix it. I'm not gonna end the video right now, even though it's 1 hour and 10 minutes. I understand this freakingly long, but okay. Let's just quickly end it up. Okay. One moment. Oh my gosh. Okay. Let's just call it the, you know what? This works fine. This works fine. Yep. No, we actually, yeah, just a bitwise state. Okay, state is, we're gonna end this with the 0x, and what should I put here? Put here 1. Yeah. So I put here 1, and then I invert it. Then I just set the inverted value, and then I just assign the inverted value. Well, it should work. It should actually work. Okay. Okay, if we mask that, so it was 0. We masked that, it is still 0. We inverted it all once, and yeah, I guess we should place this one, okay. And 0x1. So this way we will be able to actually do this operationally on first bit, only on first bit. So we'll have the first bit inverted, in this state. Okay, so we masked it, then we inverted it, then we masked it again and inverted it. No, we should actually firstly invert it, yep, and then we should mask it, yep, then we should mask it, and 0x1, perfectly. So this way, okay, if it's 0, it will be 1, then we'll actually invert it, yep, this should work, We could have done it with if else, but who cares? Okay, probably it should work. Let's go. Oh my gosh. Late to work, I don't know, I just, guys, whoa. Like, I have some test at university today, I have a work meeting today, and I'm just gonna do that stuff, because that's really cool. Yay. By the way, I hope you don't mind this sound from the bed mic. What the fuck? Excuse me, what the fuck? Reset it. Dang. I'm not able to actually flash it. Oh my gosh, oh my gosh. Why am I not able to flash it? Like, why? Checking the ports. Okay, maybe I should just reconnect that stuff to the other port. Sorry, camera. Okay, let's go. Yep, everything is now correct. I don't know why it didn't work here. Okay. So I'm just gonna. Why does it turn on? Like, okay. I'm just gonna unplug it again. Plug it here, plug the camera, just to test it again. Okay, if it won't work, okay, we'll see you tomorrow, but I hope it will work. Please, please, just one more time. One more time. Okay. The camera. Pretty dark, yep. I know. The screen. Yeah. Let's make some requests. Let's make some requests. Okay. Let's go. Let's go. Okay. Green one. Turned on. Green on again. Fuck. Okay. Okay. Red one turned on and now yellow, of course. Okay. It didn't work the way I wanted it, but it did work somehow, so that's pretty cool. I hope you enjoyed this, guys. This video is freakingly long, but I hope you enjoyed this. Thanks for watching. Like, hit the like button if you really enjoyed it. Any comments, any suggestions, any questions, I would be eager to answer them. Subscribe, yeah. Where I already have that 32 subscribers, that's cool. Let's build our community. So there was embedded day 8 or 9, 9, yep, 9. Um, thanks for watching. See you tomorrow.